Are we ready? Please have a seat. Welcome, everybody. Good morning. I hope you had a good evening at your home or yesterday. Thank you very much for the dinner for our host. We're gonna start the second half of our workshop, and Sigi will be chairing the session, so I'll let him introduce it.
All right. So we are going to talk about citizen science data flow success stories. And I saw in the presentations that we have some really cool things coming on, including hardware, which we haven't seen quite as much. Before we start, we have another Menti session online. It is a different link and a different number. So for everybody online also, please go ahead and... This is a fire alarm.
It's a drill.
It is false alarm, it's just very loud. 30 seconds only. All right.
It was just an exercise. Testing that the fire alarm works, and we can be positive. It works.
So who smoked indoors? Anyway, that gave you all the chance to log on to the Mentimeter. And we also do have, again, the first question. Please share your email address with us. Thank you for putting that on. That would be very helpful, again, for getting back to you and get in touch if you have any questions that we can't answer or anything that you would have in addition to what the speakers are saying or anything that they should know. That would be very helpful. Okay, I see we have 8 people online on the Menti. Maybe we'll wait a little bit for that. And potentially, should we just share the link again?
So as in yesterday, the QR code on every slides is the Menti QR code, so you can jump in anytime.
All right, and we have one question. So here would be the QR code as well. So one question that we have, we have 31 people. There you go. So you can start thinking about it. Is what are the most current challenges that you are facing and encounter when working with marine citizen science data? So this is the one warm-up question that we have, and then we'll go straight into the session. If there's anything that you have encountered that you thought, there must be a better way, that will be the place to put it. Whatever you found tricky. All right, now this is the challenge that we had yesterday. Now we are seeing the names. Sorry. I'm not sure we can change that until we switch it off and on again. So we'll just leave that on here and hope that people are happy that everybody else knows what challenges they are facing. Might be good too. All right, data quality, standardization, missing fields, formats, verification, of course, the funding. We've heard that quite a bit, of course, sampling bias and Giving a few more seconds, and then I think we can switch over to our... I'll leave that on, but I want to introduce our session right now. And I think our first speaker is Alessio, if I'm not mistaken. No, Juan. Okay, we have a different version here.
Refresh the PowerPoint, because the...
All right, I think we have a newer version on Drive, huh? Because the first one should be Alessio.
Yeah. I changed it. Well, actually, I fixed the agenda.
You fixed the agenda and...
Oh, no, the agenda was right. But,
All right, there you go. Perfect, thank you.
Thank you.
Hello everybody, good morning. My name is Alessio Maronne. I'm a researcher, a PhD student within the University of Malta Oceanography Department. And our group is working on several fields of research. One of these is indeed citizen science. What we work most are three main fields in citizen science. We actually run three different campaigns. I will not go into the details of all of them, but in particular I will be focusing on Spot the Alien campaign. Just to give you a brief overlook, the Andromeda microplastic campaigns relies on the use on a app provided to the users that they just want to enjoy the beach. And then with a provided kit, they can sample a volume of sand, take out the plastics, and characterize them through the app. The app has an algorithm able to identify degree of roughness, color, and surfaces, and so on and so forth. This is feeding two objectives. One is the actual removal of the plastics, and the other one is to provide us with data. This is still, let's say, a work in progress, but the prototype is working quite well. And Spot the Jellyfish and Spot the Alien are quite similar campaigns, so while I'm talking about Spot the Alien, it's basically the same thing as Spot the Jellyfish. For those not familiar with alien species, those are all not indigenous species that might be found in a country or in a sea or in a region, and they are obviously coming from other regions. Most of the times due to the intervention of men, either directly or indirectly. Directly, like as perhaps you might know, as through the ballast water or the introduction of pets, like for the tropical pets industry, but also indirectly by opening barriers, such as the opening of the Suez Canal, or even the actual climate change is removing with the ocean warming, the physical barrier that was constraining some species away from the Mediterranean Sea. There are many threats posed by alien species in the ecosystem, so that's a concern that many countries and many researchers are trying to address. And obviously, one of the main challenges is tracking them. In doing so, we launched back in 2016 a citizen campaign called Spot the Alien. And how it works? Well, the campaign has been running since 2016, but it has a structure since 2021. And the structure is based on the outreach and the engagement, because it's the core, I guess, for all citizen science campaign. So first of all, we have a campaign website where anybody with a record can input his record, obviously providing all the required metadata. And also we launched across the years several events to target like some specific groups that might be involved with alien species, such as divers, anglers, or the simple snorkels, anybody that might come across them. Obviously, to increase the interest of the public, we even gave prizes. So, for example, last year we have given a GoPro in change of the first record of a lionfish. As some you may know, the lionfish is spreading in the Mediterranean. It's basically everywhere in the Levantine Sea, like in Greece, Turkey, and we are expecting it to come anytime in Malta as well. So we are issuing a prize to the first record. And obviously, one of the main platforms to share information and engage people are social media. And about that, we'll go back to it in minutes. So the submission, as I say, like it can happen through the official web page, but we have found some difficulties about that because people, most of them, are quite lazy, so they prefer the direct contact with the researcher. So they come to us through social media, so Facebook, emails, or Instagram itself. Each input, each record must abide to some minimum requirements, which are the requirements we ask them, and soon I will list them. Obviously, all these requirements are very important to define the demographics and the environmental data to characterize the record itself. And validation also it's a key point, since alien species are quite new species to most of the people, including researchers. And some of them are very cryptic, really difficult to identify and distinguish from the natives. So some of the metadata requests are like the basics, like the date, which the date is not an indicator just of a time. It also gives extra information even about the season, and that we can analyze even later on. The georeference location is also extremely important, sometimes difficult to obtain. Therefore, we have the face-to-face interaction with the submitter in order to get a posteriori a georeference position, obviously input by the researcher itself. The capture observation method is very important because it's really linked with the target group. In our case study, we have included 4 different target groups, which are divers, anglers, including all the hook fishers, professional, recreational, or even using nets, and we have snorkels. All those snorkels include all people approaching the sea in a very casual way, even just by walking like in a marina, on a dock, and spotting something unusual on the water and taking a picture. And finally, we had the spear fishermen, because that group is like a bridge between divers and anglers, so they might have a different perspective of what's going on under the water. Obviously, the habitat, it's another factor I like to take into account. And we have categorized in 4 macro categories, which are like harbor, not usually known as hotspot for alien species. And then we got simple rocky bottom, sandy bottom, and open waters. We also ask an approximate depth of capture observation. And finally, the number of individuals. So this is the matrix you obtain after collecting all this data. And that can be provided by either in Excel on CSV, which is like the best format for data analysis. And moving on, we have some of the results obtained. This is actually part of a paper being drafting. And here we collected more than 500 records from Malta in the time frame of 4 years. It might not sound like a big number, but recently we have participated to a joint paper, including several countries around the Mediterranean, on unreported alien species, and consider that Malta alone, considered like a very small country, submitted as half as the records from all Italy, all the researchers in Italy working on alien species. So it's a consistent number. So as you can see from the pie chart, we can see that half of the submissions were from anglers, fishermen, so giving us insights, so like the interest of these people towards the alien species, followed more or less at the same level by divers and snorkels, so all tourists and like swimmers, like just approaching the beach. And finally, the spear fishermen, which is a minority, but it's not a minority because there is less interest. It's just because it's a less expressed category of users. So there are like way less spear fishermen compared with the other categories. Really important is this bar chart, because we have like a lot of information from it. First of all, we see the number of records per year. These records have been increasing year by year, and you might ask how come. Well, if you compare it with the number of social media posts like published to engage the people, well, it seems like there is a trend, like quite they go like they increase together. So the more we engage with people, the more people get interested in submitting new records. And then the small bars represent the number of records per season. As you can see, like spring, summer, autumn are those seasons in which we had more records. We winter get in the list. This is not an index of like less alien species in winter, but simply because there are way less sea users in winter. It's a simple bar chart showing the most abundant records per year. So it can give us even insights about the most present and reported species, but also we can see pikes of occurrence. Like in 2025, we have seen the blue-spotted cornet fish exploding in population and in sightings, compared with the other years where was like almost disappeared, like almost nobody was recording it. So there must be something going on in the ecosystem. Obviously, you can build maps. These maps represent the one on your left. You can see a map with all the records being reported from Malta and interpolated through kernel density. The other maps, instead, are simple spatial joint because you cannot really do a true interpolation, since this is not like a planned sampling effort. So it's more reliable just including the reports within a fishnet and giving you like some more insights or like where is more probable to catch a species. The issue with citizen science and alien species are the bias, and they can be actually a lot. First of all, this is like citizen science is not a systematic and standardized sampling method. So like we need to treat this data quite carefully. The mean of capture is also not and even the spatial pattern are not like clear indices. Like if we look at the spatial distribution, well, if you look at Malta, you have the north coast is pretty shallow and accessible, while the south coast is made of cliff. So that means that most of the fishers are going towards the north coast fishing rather than the south. So that means it doesn't mean in the south there are no alien species, but they haven't been reported much. Seasonality, as I mentioned, relies on the weather condition, and the habituation is another factor and not secondary. Indeed, a sea user, like coming across for the first time into an alien species, might be curious and sending us a report. But then once the alien species is becoming stable and settled in an environment, in a community, well, the species is naturalized. And therefore it doesn't catch anymore the attention on a user, and then it wouldn't send any report anymore. So that's why we run the campaign with posters, even to push them to provide us even more reports, even though they are species quite known. Finally, so we can say with a good degree of confidence, even from other studies, obviously, the citizen science, if well structured, provide valuable insights and data set. obviously we need to have a clear and well-planned data flow. So to have one or perhaps two data managers, people involved properly only on the identification of the species and the validation, and so on. And obviously, these data sets may provide insights for future planning, for the managing authorities, and for the detection of like early occurrence of new alien species. And also on a country level, it can provide a very useful baseline data set for again future monitoring and managing actions. That's all for me. Thank you.
Hello. Hi. Yep. All right. Thank you. I think we have no questions here immediate, but we'll check the Menti later on. And the next speaker is Juan. Thank you, Alessio.
Oh, I got the device.
Excuse me?
You have the device.
In the box. Always.
Hello, everyone. Good morning. First of all, I would like to thank you for attending this presentation. My name is Juan Martinez from CMCC, and I would like to introduce you to some scalable and affordable technologies that we have developed at the Advanced Observing System Research Unit, CMCC, that can be used for for coastal and estuarine monitoring. This is the green one, right? Okay. First of all, for those who don't know what CMCC is, I would like to introduce very briefly is the Euro-Mediterranean Center on Climate Change, and is focused basically in international research foundation focused in climate change and its impacts and interactions with society. It's formed by many institutes based in Italy, from north to south, from Milano to Lecce, which the headquarters are based. Most of the activities carried out by the CMCC are advanced climate science and impact research, climate modeling and forecasting from regional to global scales, which is one of the most important activities of the CMCC, but also climate data, digital tools and visualization systems. There are groups working on socioeconomic impact and policy support. We have fellowship programs and training programs also. And we're working on development of cost-effective technologies, which is the main focus of this presentation. Among these institutes, there are a lot of divisions also, and I would like to focus on GOCO division, which is the Global Coastal Ocean Division. We are as AOS research unit, part of this division, and we are focused on research and development in coastal climate and ocean forecasting, modeling, resilience building, and sustainable blue economy strategies and solutions. And the Advanced Observing System Research Unit is based in Civitavecchia. We are a multidisciplinary group from oceanographers to marine biologists and electronic engineers, which I'm part of these electronic engineers. This presentation is going to be focused a little to the technical issue, so apology for that. And some activities that we carried out are the development of these affordable and scalable technologies, integration with these technologies with commercial instruments for coastal and oceanographic monitoring and studies. We participate in citizen science initiatives, and we collaborate with multidisciplinary groups also. For example, a startup in Viterbo, which is called Nature4. They have a lot of experience in inland or terrestrial monitoring and development of technologies. And we also collaborate with the University of Tuscia, with the students of the University of Tuscia on activities and efforts of conservation and restoration. As I already mentioned, with Nature4, we have a very strong collaboration. We decided to start developing these devices for oceanographic monitoring. We started with a data acquisition model that is ready to get information from different sensors to monitor different variables. This device is enough powerful to process the data inside and then store the data in memory and transmit the data depending on the transmission technology available in the site. It also incorporates a photovoltaic system to permit this device to be autonomous for a long period. The procedure to create any project for technology development is starting with the design and choose the different devices. Then the development, for example, here I'm showing you the development of water level sensor from a distance ultrasonic sensor. We choose the device, we prepare the device for weather conditions, and then we made the calibrations in the laboratory. Then we made the tests in a pilot site in front of the laboratory, and we made comparison with well-known devices that we know that are accurate and precise, and also against a tight gauge managed by ISPRA, which is the institute in charge of the tight gauge network in Italy. And now, once we know that it's reliable, we create this interbox, which is this small box here. From one side, there is the water level sensor, the ultrasonic one. And we are working still on many improvements. For example, we are adding this cone to protect the sensor for fog, for heavy rains, for water to get inside the sensor. And on the other side, we have a PTH probe, which is pressure, temperature, and humidity probe, and that we are using to get all this information in the layer between the ocean and the atmosphere. And talking about development is not only the hardware and it's not only the device, it's also how we made the information get to the final user. For example, we can use a cellular network to transmit the data by different protocols. We're using MQTT, which is a particular protocol. Then the information arrives to an FTP server, quality control processor is applied, and then we send the information to the EMODnet platform. And the same with the satellite network. If we don't have access to cellular network, we can use the satellite network, more or less the same procedure. And finally, if we want to make like a network of radio frequency communications, we can use the LoRa network. So all the devices, we can put a lot of devices in an area, all the devices transmit the data to a gateway, and then we send the information also to the EMODnet platform. This is an application. We recently installed 3 sensors in the Po River, at the delta del Po River, which is a river in the northern part of Italy. Together, these 3 devices with CTDs, commercials, we are acquiring data to understand or study the interaction between the river and the ocean in the estuarine zone of the delta del Po. We would like to add as many as possible to improve the spatial resolution in that area and understand better this kind of phenomena. Also, this technology is part of the decade of Cost Predict from UN Decade program with the DCCCR program, which is the Decade Collaborative Center for Coastal Resilience in Rimini at the north part of Italy. With this program, we used to go to the place where the device is installed with high school students. We made a training about how to measure tides, how to measure the water level, and how to maintain the device, how they can help us by doing citizen science, by installing this device or removing the sensor if it's damaged, for example. Or here there is a filter to avoid water getting inside the PTH probe, so they can go remove the filter and put a new one. And they can participate with us to get good data. And I would like to mention that in the same place, this is information from that is displayed in EMODnet from the same station. The upper part is the water level measurements, and the lower part is the atmospheric pressure. So as you can see, on October the 5th, we could register a change in the pressure, low pressure that matches with a high water level sensor. After analyzing the data, the people that was working with the data could determine that it was a meteo tsunami and was new in the place. So the information acquired with this device helps for this, and this is the kind of phenomena that we would like to get with this device. I think I still have time for the last slide. The device developed is intended to be used also for other applications, not only for water level measurements. So a minimal configuration of the electronics can be used for example, truck turtles. There is a novelty in this, a new thing in this turtle tag, which is that it include also the measurement of the motion of the tag to understand the behavior, but also incorporates a multispectral sensor that is used to measure the wavelengths of light. So we can determine how depth the rise of the sun can get in the water column, and can be used this information to understand study water quality, water composition, or the photosynthetically active radiation monitoring. This is a particular test that we made with Bruno, is the name of the turtle. He's a nice citizen that wanted to help us to test the device. And the journey of Bruno lasts for 2 weeks. More than 2 weeks because the first 2 months, excuse me. But more than 2 months because the first 2 weeks, Bruno was kind of shy. So he didn't want to come out from water and send us the information. After 2 weeks, we started receiving the data, and then he went from central Italy to the northern part, and then he decided to go to Croatia, and that's the last data we have from him. And well, that's it for me. Thank you very much.
Thank you. All right, any immediate questions? No. Okay. I guess before we are going into the explanation of the rest of the day, maybe we can have Alessio and Juan up here, and we have some questions on Menti, I think. If you want to join me up here on stage, then we can ask or respond to these questions. Juan, do you want to come up here as well, or should I come to you? All right. Yeah, Juan, what's the price of the box? And how do you see this being applicated by citizen scientists?
Okay, the first question, what's the price? It depends on the transmission technology, but it goes from 300 euros to 500 euros for the construction of the device. So more or less between 300 and 500 euros. And the other question is?
How do you see this being applied by citizen science?
The idea is to engage people to adopt one of these interboxes, to install them in the city that they live. And I think the best way is to engage them to maintain the devices, because we can make the installation, but since we are based in Civitavecchia, people can go in the same city to give the maintenance, maybe to download the data or to control that everything is working properly.
All right. Well, we'll stay with Juan for now. How often does the device require maintenance on average?
Well, I think between 3 months and 6 months, depending on the site. If there is a foggy site or depends on the weather's condition also.
All right, then we have 2 more coming in here. Are you planning to commercialize the device? Are you going to sell it for a good margin?
I don't have an answer for that.
Well, how do people get to the device, though? Are you planning on giving it out? Yeah.
It's in the Scoop catalog. It's in, and the information how to get to us is also there in the Scoop sensors catalog.
So people can get it from you? Or is it even... Can they build it themselves?
For now, we are building the devices. We have to decide if we can or we want to share the technology also, but that's something that is still on decision.
All right. And then last one here, what is the communication method the device is using? I think you partly already responded.
Okay, and it depends. Can be used the cellular network or satellite network, or radio frequency. And also Wi-Fi, if you have a Wi-Fi spot near the device, you can use it also.
And that depends on what's available.
Exactly, yeah. But must be asked the different type of technology.
All right. Does anybody else want to ask some questions so that I'm not the only one here? But Alessio, we have a question here. We have overproduction of jellyfish in our southwest coast of India. How to go about that in terms of data collection and potential use of data? Do you have any tips?
I mean, we are actually working on jellyfish, and one of the new technologies we are trying to apply on them, it's the use of drones. So like we can map, and we algorithm and imaging processing, we can kind of quantify the amount of jellyfish on a sea surface, of course, like as long as a drone eye can look at.
All right. When you say photo, what cheap camera will be useful for photo documentation? Do you have any?
I mean,
suggestions?
like if I had to give like an actual recommendation on cheap camera, the cheapest good camera, it's like there are like several compact camera such as the like Olympus TG6, but also the cheapest way is probably using any GoPro. A GoPro makes the job. Yeah, pretty much. You
All
get
right.
decent quality.
And it is somewhat water resistant, is it?
Then yeah, the GoPro is like the cheapest solution, because even
Yeah.
with the compact cameras you need the proper housing, and the prices like can go up quite a lot.
That's fair, yeah. All right, then we have a question. Do you have ideas on how to scale the project to many more users, since you need quite a personal approach with each submitter?
That's one of the main issue, because I mean in Malta it's kind of easier because it's a very small country, but I believe like on a national scale of like a proper countries, that's more challenging, and the best it's still through channels. Like I know colleagues that they make constant apparitions in TV shows and so on. And the point is, as I was discussing yesterday with a colleague, like it's to educate the consumer to submit through the portal. Otherwise, the record won't be accepted, because we can do it still when it's on a small scale like Malta. But when it comes to a big scale, it's unsustainable.
Yeah, and that
I think we need to move on.
we need to stop.
Yeah, I'm
All
sorry.
right, then we'll try to respond to the others online or through various channels. Thank you. Thank you so much. And now for the explanation of the next session and the whole process,
5 minutes.
Peter and Antonio, please go ahead and tell us what we're in for.
Yeah. So we're moving now. We have seen two very nice examples of action and projects that are building on top of citizen science. Some of these data are already flowing into key marine integrators. We have seen the nice tool that Juan presented. So they are really close to accomplish, what CS MEC1 is aiming. But now the idea is to set some more thoughts in order to help other initiatives to scale up.
Yeah, that's it. And not only today, but also yesterday, we saw quite a lot of examples. And even when you... Yeah.
Very tall, Peter.
I'll just point it upwards, then it works. Even when you think it's the domain is large, it's even larger, and there's a real difference also thematically, different disciplines, different devices being used. Sometimes really structured diving watches, these applications that we saw, the cost-efficient sensors. Sometimes more human-driven, collecting observation data in a spreadsheet. And in this session, we will try to go a little bit deeper on what when we speak about fair data from the research domain and maybe the consultants later that will want to use the data, what they see as the ideal before being able to assess the data and to know at least the quality that they can foresee. It's not necessarily high quality, but the trust is already in if the metadata is sufficient to judge, is this useful for my case, yes or no? So yeah, we will go a little bit deeper in the what the fair data means, and then we will look into metadata. Data will give examples what we would expect, and then compare to certain data from initiatives. Yeah, I can skip this one, also for the sake of time. You've seen the agenda. We split it into into 3 cases. One on the physical parameter, one on the biodiversity. I see I didn't take the last agenda snapshot, but one is on biodiversity, run by the colleagues from VLIZ. They will also analyze one of the their data flows in the citizen science initiatives, and one on litter, marine litter, that we saw also pass by yesterday. And they are examples, and we hope to trigger the discussion. And also, even if we could be very firm and say, yeah, this is what we want, we're also looking for a kind of conversation with citizen science initiatives. What is feasible? I mean, we can set the standard really high, but we have to see, of course, what is feasible in for structured sensors. It's probably more feasible to do it because you only have to program it once, while for other cases it's more complex. But in the end, you will find on the CS Mark 1 website then recommendations per discipline data, and then with some examples how we foresee this to be optimized, this fairness. So.
Because the first one.
And that's us.
Yes.
Yeah.
But
so
we pick it up, I mean, the example from Dan, because that is a very nice example, because it's combining technologies and a critical mass of people that are doing the activity. So it has a very big potential. And so as we start the discussion, as you said, I mean, the idea now is we went through, we are going to go a bit deeper in some of the technical things that are behind the data flow of this technology. So we are going to address some of the missing points that we already identified, but at the same time, we are asking you then, but this is, a co-design workshop, so we really encourage all of you to address ideas and problems if you see similar aspect in the initiative that you are running or you want to run, because that is also, as you said, helping us to identify, let's say, the kind of limitation or things, challenges that we need to face in order to elevate, make the different steps for the technology and the platform in order to be consumed and usable. From the marine integrators, it is the main target, but from a wider network of stakeholders in general.
Yeah. So, Dan.
Yeah, Dan, please.
You could kick off this session, please, with a little bit of recap, maybe also from yesterday, but that's not a problem.
Yep. You can. You steady, and we sit there.
Need to lower this a little bit. Not quite as tall as you. Right. So yeah, just I guess a little recap on the data that we're collecting as divers. I've split this into 2 categories. So. Our dive computer, majority of divers nowadays will have a dive computer with them. I think this is essential to the success of this whole idea of enabling divers to become citizen scientists by default. To get the mass number of divers, which I think is the biggest challenge, we've got to make it super easy, reduce as much friction as possible. There's some other projects that are using external sensors. That's just which is great because it's going to improve the accuracy particularly on the water temperature. But it's another pain point. It's another thing divers have to go out and do, and you're just limiting the potential. So the dive computer, for those who aren't aware, captures the dive profile. So the depth, the water temperature over time. Many dive computers will have a GPS or the modern ones, more expensive ones, will have a GPS signal as well, but that stops as soon as you get into the water. But at least you can typically capture the entry and exit points. And then you've got the metadata about the device, so the make, model, and sample rate. So they can all be used as, I said, the metadata to make some more informed decisions. And moving on to the next one, manual input. So divers can also add additional information to this. So water type, freshwater or saltwater, the visibility. We don't require a diver try and give us that in meters because that can be a bit tricky. So we just say, I can't remember the exact values, but poor, good, fantastic. And then current, again, similar sort of measurement. No one's going to be recording meters per second or whatever they measure current in these days. Surface conditions, similar sort of thing. Trash, debris and ghost fishing gear. Another thing we capture, but I think it's another key point. And then, of course, photos and video. Many divers now have a GoPro or even their smartphone with a housing in it. The cost of these things are getting really more affordable, and everyone loves to take pictures of nice marine life and whatnot. So these are all data points that can be fed in. So yeah, that's a recap of what we're capturing. And then the challenges. Where do we start? I'm going to put them all on here. I think the three main ones. So we touched on sensor inaccuracies yesterday. This is I think a known issue. Particularly the water temperature sensors in these things aren't amazing, but they're not bad. I think they're good enough for now, but until we really know the use cases, I don't know how accurate we necessarily need to get. But there's definitely things we can do to improve these, and I think ultimately this is in the hands of the manufacturers, who are Garmin, Sunto, etc., to maybe externalize the sensors, put a more expensive sensor in there, and these dive computers can have external air pressure gauges that attach to your tank. So there's no reason we can't put an external sensor that also connects to your dive computer. So I think there's things to do around that. I think the main challenge really is just scaling this up. How do we get to the millions of divers that is needed? Because diving's not like sticking a sensor in the bottom of the ocean that's recording 24/7. It's maybe an hour or a little bit more at best, multiplied by however many divers. So I think to really reach the full potential, we've just got to somehow engage. I'm not sure how many. There's approximately 6 million active divers around the world, maybe averaging 10, 20 dives a year. So how do we really convince them that this is something they need to do? I think we just got to make it as effortless and frictionless as possible, rewarding, gamification, all that kind of thing. So, yeah, what do you guys think?
Yeah.
Okay. Yeah, we've
Yeah. Any ideas on, I suppose, on the engagement side of things? Is this other challenges other citizen science projects have had? I assume so. I mean, especially when you're trying to scale something globally, I suppose quite a lot of the projects are maybe more local or regional, but yeah, from our point of view, I think social media is a key thing to building that community, and that's something we're definitely struggling with. But yeah, to get this to the millions of divers, you got to build that community, and that's the challenging part. And I think also we've got to be able to tell the full story, show them ultimately how this data is going to be used. It's all well and good saying, yeah, we've got this data, we're sharing it with EMODnet, but now what? How's this saving the planet? How's this restoring oceans? How's this protecting the marine life and all that kind of thing? So if we can't tell that's like have that feedback loop, then I think we're hitting a little bit of a brick wall there. So I think that's the next kind of thing we need to figure out. And then just finally, another challenge, particularly with our platform, and I think a lot of dive logging platforms, is that you're typically out on a boat or somewhere where the signal's not great. And actually, I think this is a problem with many apps in general. They're essentially just websites wrapped in an app, and therefore require an internet connection. So as soon as you lose your internet connection or have a not so good internet connection, the app just stops working. So this is a key thing, and it's not an easy problem to solve. I mean, if you have an app that's fully offline, that's not bad. If you're fully online, it's great when it works offline, but when you've got to sync to the cloud and work offline, there's some challenges around that. So that's something we're working on with our next version. But yeah.
Good.
I know you also had a slide, I think, a little bit later on your data model. Maybe you want to pop that up before we...
Yeah, so this is sort of... I'm going to figure this thing out one of these days. There we go. So this is now moving into sort of the biodiversity stuff. If we want to go down that, get into that a little bit more.
Well, biodiversity is more the next session, so we can stick to the physical side. But
yeah. This is the graph we presented yesterday. The next slide is on the biodiversity stuff, so I'm not going to go there just yet. This is the dive profile essentially that divers are collecting from their dive computer. So we've got the temperature. You can barely make it out actually, but there's a little dashed line that demonstrates the temperature. On the x-axis we got the elapsed time, and on the y-axis we got the depth. So this sort of demonstrates how a dive looks over time, and we're also able to, we'll be able to soon plot any observations, and that's getting into the biodiversity stuff on this same graph. So yeah.
Good. Thanks. Thank you very much. Yeah. And maybe Dan, you can stay with us.
Stay here. We're gonna need.
yeah, thanks. So this was the current situation as it is. And now I want to present shortly, not too long, but the target as we foresee it now for the data, because this data is being collected. I want to come back before I go in there to one of your questions, which is not the focus of today, but you said about the engagement. And what we see that works is to give back to the divers information related to their own observations. So you could be thinking of setting up a dashboard, maybe in together with EMODnet, in the same area where the diver has been, that they can see that the observed temperature by EMODnet in his historical data, or show a Copernicus product.
Beyond
globe, maybe even a prediction in that area. You could think of that, especially when it comes to visibility. I guess that will definitely trigger.
But this is also part of the discussion that we need to keep having. Is also should work. Is also thinking about which are the complementary information that could be useful to attach, to present on EMODnet when we are presenting this data. Because that is, for example, one easy way to show they are contributing to the system and to the platform. Because we also have to think about that EMODnet is somehow a data system, is an integrator system, and then it's serving other initiatives that are making also the value of the data. So having, the logo or something that can give credits to the people that are participating is important. It's important for EMODnet as well, and it's important that we get feedback from the people in order to understand which kind of course we need to find a balance on what we present on that, but of course we can improve on that. That is a clear recommendation that we can give to the system.
Do you want to just someone who's really eager to get hold of this data? A quick one, pretty quick. And I think I told you that story because I was at a conference some time ago, and this came up, and someone in the audience pointed to me and said he's working with scuba data, and I had a modeler from Rutgers University in the United States just saying, "Where's the data?" I said, "You got to give us a while to get this organized." And we start talking about what they're going to use it for. And he was so eager to get hold of this data for their hurricane forecast on the U.S. East Coast. He never questioned the quality of the data. So I was the one who has to ask you, usually people they criticize the quality and say, we have nothing. This is fantastic. And whatever products and services we make based on that data, we're happy to share with you guys so you can reuse that in turn. So it's just one of a pretty strong example of how this can be useful. So it's important stuff that we're doing here. People want it. They're really looking forward to getting this data.
And you have already addressed again one key point. It's not about the quality of the data, but it's documenting the data. That is the introduction.
Yeah. And it's getting more and more that we're not necessarily chasing the decimals for data. And it's also like I was mentioning yesterday, this is complementing the current ocean observing system, where we have the current system with the more advanced platforms and the decimals that we are chasing. But with this, that's not the case. It's getting more information and more complementing the current system.
Okay, let's look at what we when we spoke yesterday about fair data requirements, in this case for physical data. We based that on the EMODnet, partly also driven by the SeaDataNet standards and SeaDataNet solutions, vocabularies. What do we see as the ideal situation? And then we can compare to what we would recommend. Well, just a precondition, you need to collect as much metadata at the moment, so descriptional data at the moment, about the deployment, for example, the moment that you actually collect it. That's in all cases. And if you look to the formatting, ideally metadata language English, and the character set, but that's more technical because that can be really cumbersome if it's the wrong one.
That is a key.
But it's simple, but
when you start having strange letters,
strange characters in suppose
then
it's
you
a
implement
French
automation,
location, or then you get into troubles. So YouTube. Okay, then this is related to my comment yesterday. What is a minimum? Well, metadata. Yeah, you could also see it as data, but it's really close descriptional metadata in the data file. What do we minimally need if we look? And first of all, is the sensor a sensor identifier? We need to know, or the reuser needs to know how it was collected. And for this, and I think I have a slide, there's two options. We have an official vocabulary, we call it the NVS, the NERC vocabulary server, and they have a code list called L22. I'll show it later. And we have the SCOOP, and actually they're linked together. So either one of them is good because they refer to each other anyway. Why is that SCOOP so interesting, that SCOOP reference? And I show here on the left, you see an overview of the whole catalog. The catalog is not only a marketplace of what's out there, and you can be triggered and, for example, find the CMCC box or the Envlogger that we saw yesterday or others to be useful for your project. But it actually also is aiming to collect information about validations that have been done. So could be from the manufacturer, could be from within the project, from the Lancelot project, for example, where they have been tested, and a small report from these tests could be entered. But it could also, in your case, for example, if it's a certain model and there's a kind of validation against another one, and you see there's always the same offset of a degree. Okay, you publish that. A user later will know, okay, it's done with this model, so I can actually use that offset, correct it. So it means that the accuracy is not in the data, but it's supported by the metadata through the sensor reference. So here you have the page of the end logger on the right, and it doesn't only give a description and where it comes from and contact information, but it also gives this persistent identifier, a PID, and you can use that in your code. So if you, and especially if it's a cost-efficient sensor and it's always the same, so add it. You have to register it only once. So add in the code in the output. Done. So it's a simple one, but with a lot of added value. The other alternative, every scoop entry does not only have its PID in the scoop system, but this is even more sustained and persistent. That's a reference in the NERC vocab server. And actually these vocabularies, if you go there and you follow that link, you probably will be overwhelmed by the amount of vocabularies, because there's there's code list for not only for the variables observed, but for instrument types, for sea areas, for a lot of things. Of course, in CS Mark 1, we will do a pre-selection and say, okay, these you have to look at. And we will go further, because in this case, for example, I have then the devices, and which is the CVOX device catalog. We will support, of course, in registering that and handing back. So that is important. And if you, now I first go back to my other slide. If we go down the list of what we minimally would see is the sensor name. So you can always add in some more information about the sensor itself in free text. Serial number, if it exists, not always. And then we go to the other but really essential data, the date time. And there, you always have the problem with local times, and that is a problem if something is applied across Europe or across the globe. So it's better to, when possible, immediately calculate it to the UTC standard time, and then recommended format. Although if it's another standardized format, we can always fix it later. I mean, but ideally, in this standard format, YYY, MMM, DD, etc. And then, of course, it should always contain a latitude and a longitude. Where was it taken? It seems like what we call in the Dutch, I don't know if it's an English statement, an open door. But it's sometimes forgotten in the output. And if you don't have it, then the data is useless. So in decimal degrees, it's often the case already, but if just to add to the recommendation. And then in the coordinate reference system, WGS 84. You can always do calculations if it's different, but and then the last one here is the variable measured. So if it comes from a standard sensor or a device like Juan showed, or the envelogger, you have to enter this only once. But you have to imagine that if data is exposed on a certain node for publication, and somebody picks it up, and maybe if it's open data, he forwards it again, and it just says temp, they don't know anymore what kind of temperature it is. So the more structured and the more referenced, the better. And for that, we can, for both the unit and for the variable, we can, and we should definitely use the NERC vocabulary server. And that is actually this slide. Again, here we will, on CS Mark 1 platform, we can of course make an overview of the most common variables like temperature, salinity, for physics at least, current, blah, blah, blah. And because there's many, it comes from the P01 directory, which is actually all 10,000s of different ones. But for temperature, this is the most common one to use, temperature of the water body by in-situ thermometer. And that's what's in this case also the diving computer registers and does. So if that's being added, that's great. And then for the unit, that should be in a separate field. If it's in degrees Celsius, there's also a code for it. So either enter the code or the whole link, but that doesn't matter as long as there's a reference that it comes from the NERC vocab server. Ideally, just include, I don't have a pointer, but it's the top line where it says URI. If you include that, but I don't know if they see online, but it's the top line, just under degrees Celsius. Yeah. Okay. Then I go back. Okay, so we had those. Sorry for... then a last one before we go and look at the dance case. The deployment information. The more you can provide about the way it was mounted, deployed, the better. I know it's an ideal case, but if the user in the end knows it's a diving computer, they probably also, the end user, they know that it's probably worn on the wrist and taken down, etc. But if it's the end vlogger, that you saw yesterday, it's really important. How was it mounted? Was it floating on a buoy? Was it stuck underwater at 1 meter depth, fixed? Was it just on the tidal line? But which tidal reference system? So the more you supply, the better. And there we are not absolutely sure how that can be exposed. But add it somewhere in the, and it could be in your CSV or in your in the metadata around it. We have to, that's still ongoing work for us, but we have some solutions, but it requires some more work. And it could also be if there's a JSON output, you add a certain snippet like this on the location, and then also about what was the platform and what was the mounting height in this case. We want to standardize it so that you do not fill in text platform, the type of platform, but that it's if it's a pole or jetty or buoy, but we also want to make a vocabulary for that. But it doesn't exist yet, so we need to set that up. And then also for the other one, is it fixed in the water? Is it floating? That's really essential for the reuse later of the data. Okay, I think now...
Peter,
please go ahead.
add on that also, let's say the name that we are attaching.
You have to put it higher.
Yeah. Also the name that we're using to identify the specific, for example, the dive, because it's always very good to have, the date of the dive together with a name that is consistent in your system, because then you can always distinguish between that specific platform, that specific thing, and offering this information, of course, should be part of the metadata, but it's also an easy way to fill other databases. Patrick was making the example of the ocean forecaster people, the modelers that are harvesting information, if they can easily get, subset information in time and space. So if we can play with this kind of information in an easy way, that's also important.
Yeah, definitely. Is there a vocabulary that you guys provide, or is there a universal standards for that as well, or do we just need to be consistent?
It should be consistent, yes. Also in that, we have some good practice that we can tell, but there is not a universal way to do that.
Yeah.
The most important thing is it should be consistent.
Yeah, makes sense.
I popped up this slide again because I think this is nice to now recap on where we were. I think in general your setup absolutely looks good, but what you register in the lab's time, the depth. Well, I think I skipped it, but it's always important. Positive is down, and so the positive value should be downwards. Water temperature, that is then the code. Ideally recommended. I want to go to the last part now, the device metadata. Do you expose that already now in the output? Because you have it, I think.
Yeah, we're capturing it. We haven't shared it with you guys yet. We've only added this in the last couple of months. We haven't collected much data because it requires users to go and add that back in essentially.
Yeah.
But when they upload the data from their dive log file, that will typically contain a lot of that information.
Information about if it's a Suunto type X, Y.
Exactly, yeah.
Is it how many different? I mean, I think it's a
There's
lot,
a lot,
right?
yeah.
There's a lot of
With
them.
makes, models, versions of the schema, all that sort of thing, and then especially when you start importing from third-party apps like MacDive and the Paddy app and that kind of thing, you start to lose that data. So then we need users to add that back in sort of manually, and then do we lose a little bit of trust?
Yeah, then it starts really getting difficult.
Yeah.
But yeah, where possible and where you have it under control, we could we should be in touch about seeing how far we can go with adding to the scoop or at least the make and the model.
Yeah.
Because if we go further to the versions, etc., then it will become a lot.
It's a little bit out of control.
Yeah, then it's out of control. So we have to see what's realistic.
Yeah.
But of course, the rest we can include as free text in it, and by that the user can already make an analysis because they know the temperature comes from a dive computer.
Yeah.
And then it's up to them to decide: it's a real gap here in my model, and I want to use this in situ data, yes or no?
But yeah, that could already solve one easy question, as you said, because you say if you have a model that is more recent than a given year, then you know that the quality of the sensor is good enough for your application, then you just filter by that.
Yeah. So that is definitely one we'll follow up. And do you think now, if you see this, how do you think? Oh, that's a lot for me to arrange in my output, or is this something quite easy to?
No, I think we're pretty close. Some minor tweaks.
From the outside, it looked like it was minor tweaks that you can do, and that's also what we hope to do, not to put the barrier too high.
It's now. I mean, obviously the data we got in there now doesn't have many of the devices, the device metadata added. So, but yeah, going forwards, if
that allows us also to slowly build it up. Right?
Exactly,
because you can do distinct, and every batch we can.
And then I guess we can add a little bit more information about whether the device was automatically inputted from the dive log or whether it's sort of manually inputted. Again, just to show some evidence and build a little bit more.
Yeah, please help us also with if you think, but this is not in your list, but for this specific case of dive watches, that is really crucial and should not be missed. We have to. And yet, as I said, the output type, if it's JSON or if it's a structured CSV, as long as it's very structured, that's the most important.
Yeah.
And it always stays the same. That's the most because then you can always on EMODnet side or on CS Mark 1 side, if we can collect it, restructure it, or read it into some kind of software and expose it.
Yeah, we don't want to be changing it every time we share a chunk, do we?
No, we should.
So I guess that's probably the main thing we need to figure out is the structure that works best for us both. I mean, we can
even fix that by adding in the metadata version of your data format version.
Yeah.
So if the format version changes, the software can also
do evolve, don't they?
Yeah. So that's about the direction we're thinking, and for similar types like the end vlogger that we saw, there's the probe, something that you can stick to your fishing rod and you can lower to the bottom and by that make a CTD. It's really similar, the approach, so we can show these cases on the CS Mark 1 website.
The Meteo Tractor is very close to this.
Yeah. And we also have there's more. So if we show these, then people will recognize it, and of course we will provide guidance and training materials, and that's up to us to create that as soon as possible. I don't know how we are in the time. I didn't follow.
we're good. We have another 10 minutes. So
For questions?
But, there are questions actually
Okay, yeah.
from online. So
10 minutes for questions.
Should I start with a Menti input there?
If you want.
All right, so well, just going from top to bottom. Is it possible to quantify the sensor inaccuracies, i.e. translate them to an uncertainty? And I think that was coming during Dan's presentation still. So I guess I'm addressing you.
Absolutely, yeah. There has been some work done already on this. There are a few projects, I think one in the Red Sea a couple of years ago, where they would essentially get a dozen or 20 different dive computers and measure the inaccuracies essentially, and they did found most of them were consistently inaccurate. So that can then be used to take that offset, plug that back into the system as metadata, as you sort of touched on one of your slides.
I'm going there. Yeah. Yeah. I mean, that's information that should we expect. Same for an end logger or anything that's registered. We can include that. Really valuable information. Yeah.
So we need to probably resurrect or modernize that. That's probably something we need to work on. Actually, is keep an up-to-date database of these, and little side project for someone. Yeah.
Okay. See. You have more from the...
Yeah. I was just wondering if anybody in here wants to raise their voice as well, so you don't hear.
Paul.
Yeah.
Only me. There's no one else? No, we do, but let's switch it up a little and...
We mix a bit from in the room and...
Thank you. So my question is regarding, let's say, the depth you mentioned before, because in the table that you referred in the metadata, you have latitude and longitude, which looks like a little bit like a fixed point. What about tracks? This is my first question. And depth, of course, since it's not in the table, you'll move it to the data.
No, I think the depth is on, but I think it fell off. Probably last time. Yeah.
In depth.
Yeah.
Too much depth.
That was negative.
Okay, so depth, no more question. But then the
track we should also, we should be able to include it, but that gives a different flavor just of how we foresee the track information then as a geo. What do we usually do? Like a string of coordinates.
Yeah,
so
multi-line or something.
Yeah.
Okay, thank you.
A good one. We need to add it.
Yeah, that is...
So far we've only had really point location information with all these sensor types. Sorry, Dan.
Yeah, I was just going to say that is a little bit of a challenge. Usually I found with these dive computers is that you'll get one reading, you won't get both when you enter. You typically get one when you enter, or when you exit the dive. But you've got to get a really good signal, which is not always the case. So if you're lucky, you'll get one coordinate. So you won't necessarily be able to figure out the direction. Then you've got to use other data like the current. Like, was I going with the current? Was I going against the current? Was there any current? Do I even know the direction I went in? I'm not a particularly good navigator when I'm diving, and I think many divers probably aren't as well. So it depends what you're doing.
You go with the flow.
You go with the flow. You just follow the shiny things, and
No, but that's actually a good one because underwater GPS it doesn't exist as far as I know. So you get one in this case. It's also up to the user. They know it's a dive computer. I get 1 point, but I somehow get a kind of a track, and I don't know where it's going. It's around that location, but you don't know the actual track. You could probably, I don't know, take an average of the depth and average of the temperature and maybe work with that. I don't know how, but that's up to the user then to decide.
There also have been quite some contributions online on the challenge of engaging divers, and they were wondering if you've thought about getting in contact with dive centers, so they can then engage their divers.
Yeah, that's something we're sort of just getting into now. So I think that's the missing piece. I mean, we're trying to engage with the different training agencies, and I think this is key to get them on board. But obviously, that's quite a challenge. So definitely, we need to go for the sort of dive clubs and dive centres. But again, it's engaging them and showing the value in it for them. I think typically diving is quite stretched in terms of funds again, and can be quite seasonal and quite competitive. So ultimately, what is in it for the dive centres? I know there's a few sort of citizen science courses within like PADI and SSI and stuff. So they were able to make some money for selling these courses, but for using our platform, currently, we're not able to give them any financial reward, but we are really working on sort of the social side of it. So allowing them to almost promote their business through our platform by demonstrating that, yes, we're logging our dives, we're sharing our data, we're observing things and that sort of thing. So there's a lot more work we need to do on that to amplify it, but that's sort of the direction and thought process of where we're going.
And on like giving back to the divers who would like give their data in, for example, is there a way to recognize who put the data in so you can like get back to them?
Well, we do need to sort of anonymize this, which something we are doing. But you can have these handles, so at least you got your anonymized sort of name. We're going to be sort of gamifying the platform and putting in sort of a leaderboard, like you did on your
with a nickname, which is something you can expose, while the other one is tricky.
Yeah. Exactly. Yeah.
Or you can add these nicknames just in a single page, so you are somehow splitting the location and the personal information with who is contributing to.
Yeah, I think that's I think one of the key things we are missing is that recognition and rewarding of divers, and said having these leaderboards, maybe giving some sort of prizes, or win a GoPro or whatever for the people who are top of the leaderboard at the end of the year, or that sort of thing. So yeah.
Well, I have a question for myself, not online. So all the things that you do from the data, the standards, the processes, is that somewhere documented as a practice already, or do we need to work on that and publish that together?
The last one.
Yes.
And Emily was in the whole car ride going here, bashing us, saying, you have to now start publishing this. So this will be document. You have to guide us on how to get it to a certain level, but let's first get it on the webpage, and then we'll see how we can make it official. It's a good start.
Yeah.
Right? Yeah.
We're here. I mean, that offer help is for everybody who wants.
We want the best recipe to brew our coffee, right? With the French press.
Yeah, great question.
Yeah. No, good point, Siggy.
But I think we arrived to the end of the time anyway. So that was the perfect ending question. Thank you, Siggy. Yeah. I personally love it very much. You just nailed our hammer on the nail. That's perfect. We have now a break. Thank you very much for this morning session. And we reconvene at... exactly perfectly on time, which is extremely satisfying.
It's on the...
we have 20 minutes.
Good.
Yeah, 20:45. Perfect, thank you.
10:45. Thank you.
we live soon. Yeah. So I think we'll start again. Thanks for taking your place. And we're gonna now give the floor to Cyril and Leen for 45 sessions. Please.
I'll start with yes. Good morning, everyone. My name is Leen Vandepitte. I work here at the Flanders Marine Institute together with Cyril, who you've already met yesterday, and we're part of the data center of VLIZ. And we're here to talk about observations of marine biodiversity citizen science data. So the data, the biological data you can collect as citizen scientists, and how that can make its way into the general data flows within Europe. Before we get started, I'd like to just give you a little bit of background on who we are. So VLIZ itself, you're here at the Flanders Marine Institute, and one of our missions is making sure that science-based knowledge is being strengthened, and that is not just about the coast, it's also about the seas and the ocean in general. And within the data center, there are several things that we do to support scientists. And that goes from a national and an international point of contact that we are, and we help with quality control and make sure that data becomes reliable when it comes in a general data flow, but also make sure that we can provide services and technologies and also tools and training to support scientists. So we're very much aware that a scientist doesn't necessarily have all the skills related to data management. So that's part of the services that we offer at the data center. Assist people in how to do proper data management. We also make sure that data is made accessible, because that is a condition in a lot of cases. Even if you're involved in projects, it's key that your data at a certain point becomes publicly available. We are, as a data center, accredited under IODE, so we are a national oceanographic data center, which means that we also not only have the possibility, but also the capacity and kind of the obligation to support people in their data management. Within the data center itself, we have more or less 6 core activities, and a lot of these will come back in the presentation and definitely deal with good data management. So the first one is focusing on fair data management, making your data findable, accessible, interoperable, and also reproducible. So that is a complete package. Our data center is part of a data network, which means that we connect with other data centers and we can make sure that your data really becomes part of a bigger flow, be it national, European, and international. That covers that whole package. As a data center, we promote and we use open science. So again, we're all about putting your data out there, making sure that other people can find it and can make use of it. Next to working on data, we're also developing or assisting people in developing data products. So not just your raw data files anymore, but specific maps or specific products that can be used in communication, in infographics, for example, really showing what the data does and what you can do. Linked to that as well is data literacy training and support. So we do provide trainings on how can you learn more about data management? How can you make sure that you do a good data management that is completely according to the FAIR principles? And we also, within VLIZ, within the data center, manage a number of European and international e-infrastructures. So making sure that people can access tools and services to do a good data management job. Now, the e-infrastructures that are mentioned, I think you've heard at least the names of a number of these, and we also realize that it might be a very complicated landscape if we throw around the acronyms. But just to give you some introduction there, EMODnet Biology and EMODnet have been presented yesterday already. Biology by Cyril and EMODnet in general by Kate, if I'm not mistaken. So you do have the background on that. The second logo on there is EurOBIS, which is the short version of European Ocean Biodiversity Information System. EurOBIS is basically a network and an infrastructure that captures the biological data. And those are the biological data that are accessible through EMODnet as well. Within our institute, we're also working with DTO Bioflow and Day2, another two big European networks and infrastructures, and all these collaborate. So if you want to share data, you only do it once. The systems and the connections between these initiatives do the rest. Just to give you an idea, biological data, focus on biological data in this talk is what do we have available? We have more than 1,400 data sets available, and we collaborate with institutes and researchers within Europe. And that all adds up to over 52 million occurrence records. So 52 million observations of species that we have available through space and time if you limit it to the European marine waters. All of that is also associated with almost 300 million associated data. And what is associated data? See that as, for example, the length of a fish or the weight of your plankton or whatever you have been collecting and measuring. All of that can be seen as an associated data records. We've also pulled the stats because the 1,400 plus data sets is everything. It's research, it's monitoring, it is literature based, and it also includes citizen science. And on the citizen science level, right now we have more or less 26 data sets available, and those are 400,000 occurrence records. That might seem very little compared to the 1,400 data sets that we have. It's true, it is not a lot, but it's only been in the very recent years that citizen science initiatives are looking for options and possibilities to share their data more widely. And this is a bit where we come in very much with EMODnet and the DTO Bioflow project to make sure that we can support and assist citizen science initiatives in taking those steps the right way to make their data publicly available. So there's different approaches possible to go to data mobilization to make your data available. And there's then, of course, different roads that lead to the result of the citizen science biodiversity data becomes publicly available. And the biggest one that we collaborate with or that we're involved in is EMODnet. So what does EMODnet do? EMODnet Biology, as Cyril presented yesterday, partly is very much focused on partnerships and subcontractors. So each phase of the project that starts, we reevaluate and we renegotiate partnerships. And then once someone is a partner or a subcontractor, we make sure that they receive the necessary training and that they get enough support of us so that they can actually make their data publicly available. Within EMODnet, what is very important, and that's the sentence or the catch that has been going since the very start of EMODnet, it's collect once and use many times. It's only by sharing your data that you can make sure that other people can find it and that other people can also make use of it. And that leads to new collaborations or new possibilities that you can explore. The second one is DTO Bioflow. So DTO is digital twin of the ocean. Bioflow, one of the projects in that big umbrella. What the DTO Bioflow European project has done in the last 2 years is they have launched open calls for marine biodiversity data to become publicly available. So anyone who had biodiversity data within their institute or within their network could write a proposal for the call and then explain how they see their data contributing to the bigger picture. And with that, so with the call, with making data available to DTO Bioflow, data automatically also becomes available through EMODnet Biology. What we have done there is data training sessions as part of the grant. So selection is made of the proposals, grants are assigned, and with the grant comes a very thorough data training, which is about mobilization, which is about making your data fair and putting your data out there. The primary goals of DTO Bioflow and the grant system that we had is supporting that standardization and that publication of biodiversity data that was until that point not available. It exists, but it wasn't available because it wasn't shared through wider networks. And what we also aim for within DTO Bioflow is establishing workflows that are at least semi-automatic and preferably automatic, which means that if you make your data part of that DTO Bioflow data stream, you don't do it just once. By looking at ways to semi-automate your workflow and your data flow, that makes sure that if new data are coming in, for example, from the observers that you're working with, that those data then automatically or semi-automatically keep flowing. It doesn't stop after the one exercise of this is how I have to make my data fair. Over the last couple of years, also very important is that if you look at the project calls from the European Commission, you very often now see references for biological or monitoring data to EMODnet Biology. The condition that you have to make your data available through EMODnet and make them publicly available by the end of the project. This wasn't the case 10 years ago. People were very much more still of, okay, I have my data, and by the end of the project, data is completed and it's okay, but it did not necessarily become part of the overall flows that make your data available outside of the scope of your project. So this is more and more in the Horizon Europe goals and also needs to be respected. So the connection with EMODnet Biology for biodiversity data is a quite obvious one right now. Just to give you an idea of the landscape, I know this can be a rather complicated thing, but just to summarize, as a data provider or as a project on citizen science data or as an initiative, even without a project, you can be in this box, which is basically all the data providers. You are the person that works with the data, that works with your network of volunteers in the case of citizen science, and you get your first view on the data. What happens then is within VLIZ and within other organizations is your data becomes part of data infrastructure at the center. And that data infrastructure is very much structured and very much quality controlled, making sure that everybody understands your data once it's in there, that your metadata is complete, that you get a full picture of this is the data, the metadata, the people that have collaborated. And from there on, the data can become available on all those other European and international networks that you have. So first of all, EMODnet Biology for the monitoring data or the citizen science biodiversity data, but also to a more global level, because EMODnet Biology is very much European, but we also connect with the global network, so EurOBIS and GBIF. And once your data can become part of the very bigger global picture, that also gives very different possibilities and opportunities to collaboration, to wider networks that you can form, and also to exchanging not only data, but also experiences at a certain level. So that's a bit how the bigger picture works. And that one's for you.
Yes, thank you. Okay, so right now that you are all aware of how the FAIR principle works, because I think you had a presentation on it this morning, now we can dive into how we apply those principles inside of EMODnet Biology. So the first one, findable. To make our data easy to find, we implemented different search option and filter for the metadata in our data catalog and also for the data in our data portal. Within VLIZ, we also have our own infrastructure for the metadata that is called Integrated Marine Information System, EMIS, and there is also a search option for you to find your metadata within EMIS. The next, it's how we make the data accessible by humans, but also by machines. So as you saw on the previous slide, we make the data available by humans through the data portal, the data catalog, but also we have the download toolbox that is present on the EurOBIS website. Concerning the machine, we have different web services that allows you to access the data layer that are behind the data portal through different HTTP requests. But this is not enough to make the data really accessible by machine, because not everyone knows how to use those web services. So that's why we also added some tutorials on the EMODnet website, and also a demonstration on how to access those data that was presented during a webinar for the UN Ocean Decade. And finally, we also have a more general documentation on those web services that is available on GitHub. The next is interoperable, and you could ask the question why we use those standards. We decide to use them because it allows us to make the data and the metadata understandable and usable by anyone. We are all talking about the same thing, which allow us to understand the data, and also we use those standards to make the data and the metadata usable by computers program, because computers program need to have precise vocabulary and terms that can be used that won't break the program. So that's why we use those standards. So the first standard that we use is Darwin Core. It's mainly for the data. It's an internationally used standards to facilitate the sharing of information about biological diversity. As you can see, it's used by very big names of the biodiversity community, like EurOBIS and GBIF. It mainly focuses on taxa and how they occur in the nature, based on different observation, and it gives also information about the sampling and the measurement that were made during those observations. It also allows to share information about biological biodiversity by providing different identifier, labels, and definition of the different data that is present in your data set. But that's not the only standard that we use in EMODnet Biology. We also, I'm not going to go too much into detail to not waste too much of your time, but I think it's interesting to go quickly through the different standards that we use. So within Darwin Core, we use also the ecological metadata language, which is a comprehensive vocabulary that is used as an XML file to allow everyone to share their metadata in the same format. Next, we have, of course, Darwin Core, and we use the EurOBIS data format, which is a more specific variation of Darwin Core. Next, within your data, it's important to standardize your taxonomy. And for that, we use the ID that are present on the World Ocean, on the World Registry of Marine Species. Concerning the measurement and the fact that you have gathered in your data, we use the vocabulary from the British Oceanographic Data Center to standardize those measurements. And for the metadata concerning the geographical coverage, we are using marine regions. The next and last is how to reuse your data. To be able to reuse your data correctly, you need to have complete and detailed metadata. To be sure that your metadata are well completed, you can ask yourself if your metadata are able to answer the 5 W's question. Next, also DOI is very important because it allows to have a unique identifier for your dataset, and it makes it more discoverable and easy to share with people so they can reuse it properly. The next one are the citation and the license. Those are very important because if people don't know what are the limits of the reuse of your data, then they will probably not reuse your data. So that's why it's important to present to actually put a license on your data set, and also they know how to cite it. It makes it more discoverable. And last, it's always important to have a contact address in case if any of the users have a question about your data set, they know who they can contact, and it will allow them to reuse your data. Here are a few common oversights that we notice when datasets are submitted to us. On the metadata level, not most of the time, but yeah, sometimes information about the project and the methodology are overlooked, but this is important to assure that you have a good provenance of your data set and your data. On the data level, there is 3 mandatory coverage. The first one is taxonomy, then temporal, and then the geographical coverage. Unfortunately, temporal and geographical coverage are often overlooked. Of course, not the taxonomic, because then it won't really be a biodiversity dataset anymore if you don't have any taxonomy. But hopefully we can solve the overlook of the temporal and geographical coverage with the assistance of modern technology by using, for example, apps or online tools that will directly capture your coordinates and the time when you make an observation. Here is an example of one dataset that was submitted to us via the DTO Bioflow grant. It's the dataset Honeymoon. Here you can see the data present on our data catalog. Then this is the metadata that are present. It was the data portal, my bad. And this is the metadata that is present on the data catalog. Next, we have the metadata that are present in our EMIS system. And what's interesting here is, as you can see, it has a DOI. There is multiple possibility when you submit a dataset to create a DOI. Either we can create a DOI for you under your specific request, or GBIF will automatically assign a DOI when the dataset is registered through GBIF. It's very important to have a unique DOI per dataset, so that's why we don't duplicate the work of creating a DOI, and it's either created by us or by GBIF. And to finish, here are some useful links that you can use to standardize and to make your data as fair as possible.
So thanks a lot. We're gonna take some questions. Is there any questions in the room? I need the microphone to run around. Oh, I have two again. No.
That was just a remark. I understood that the Menti was not on this slides, so they have probably not, people online have not been able to use the Menti. Yeah, that's the way they can provide the feedback. So I don't know if it was it still on the first slide, because maybe we can bring that.
Or we can reload this slide, because I added the QR code.
Ah, yes. Kun je herladen achterin? But maybe we can do some questions first and then.
Well, we have one on Menti from Nancy.
Okay.
How to reach out to EMODnet Biology as a coordinator, as a citizen science coordinator, to become a partner or subcontractor. What are the conditions and the needs? In brackets, some citizen science projects are not run by knowledge institutes, but NGOs or communities.
Yes.
The consortium for the current phase of EMODnet Biology is shaped. We cannot change that one, but we can check for next phases of EMODnet, which will be in a year and a half. We'll normally start the next phase. That doesn't stop you from still reaching out to us and letting us know that you have an interest in making your citizen science data publicly available, because we can always check what we can do right now to help you maybe just have some pointers on this is interesting material to read, this is interesting to catch up to. And just because they're on here right now, nope, it's gone. The last slide that had the overview on the training courses that are available, they are freely available. The one on ocean data management and biological data management are opening this month. They're on the Ocean Teacher platform, but you can just register and start going through it. Ocean data management is very much focused on what is FAIR, the FAIR principles. How do you apply the FAIR principles to your data? It's also about a data management plan and the full research data lifecycle. And research data, you can look at that very broadly. That does include citizen science data lifecycle. You need to have a plan, you need to have an idea of where you're going with your data. The biological data management training course then really focuses on how to format your data according to Darwin Core, how to do your quality controls and all that. But these are also things that we can directly one-on-one assist you with. Just send us the questions.
Yeah, just want to come back to this because I think this is really important materials for the CS Mark 1 project, because we cannot, as you say, not even under EMODnet Biology, but also not under CS Mark 1. We're not able to provide funding to citizen science initiatives to do the work on the data, but we hope by providing the training materials, sample cases, the documentation, that we can trigger citizen science initiatives to do the work on their end anyway. And if you can provide the guidance, even some support, that's already great, I think, to do under CS Mark 1 and under EMODnet Biology, of course. Similarly, it's the same approach goes for the other data types that we discussed today as well. Like in the case of Dave, we cannot provide funding, but we can provide all the guidance with training materials and recommendations. And by doing that, the citizen science initiatives not only makes them data fair for uptake by us, but also maybe at a national level or another thematic harvester that wants to use of their data. So it is a win-win that we hope to create. So thanks for this material we can include.
Done.
Really quick one, hopefully an easy one. How do we contact you?
We have plenty of info addresses that you can contact us on. What is it? Info at EurOBIS is a possibility. You know what? We'll list them and we'll get them to Peter. And we haven't done that. We forgot about that. Sorry. But we'll get the addresses to you so there's no confusion there.
Perfect. Thank you.
But I think I was actually asking Joseph from the CS Mac 1. This is probably on the website. We should try to put a place and where we can make an announcement for this kind of class you just mentioned, course online, and just another channel to inform the people about the possibilities.
There is a question on the chat. How would you envisage users being able to identify data as coming from citizen scientists in EurOBIS?
They should have a tag. Yeah. And at least and this is where we're getting back to the metadata that is so important. Your abstract or your summary of your data in your metadata should at least contain one sentence that your data comes from a citizen science initiative.
So when you say did you say you should have a tag, or?
The tags are mostly assigned on our end. So for EMODnet Biology, every data set that comes in that is a citizen science data set, we give it a tag ourselves, but it should still be in your metadata. We need to extract from your metadata that this is a citizen science data set.
And what are other tags you have?
Monitoring data, literature-based data, research data. those kind of things.
No other question? Is there anything on the Menti or the chat?
We have one other one on Menti. We used worms for our identified fish species based on ILK in southwest coast of India. We found it useful, but also some challenges. Sometimes we had accessible issues. I don't know if that is something that you can respond to.
Define accessible or accessibility issues.
I can't design more than...
And then what's in the chat then? No. Worms is open, freely available online, has a number of services, so you don't have to look up each name one by one through the search. We have something that's called the taxon match tool, where you can run your full taxon list too, and then you get the identifiers back, or you get a notification that it cannot be found, or there's more than one issue, more than one possibility in your match, and then you do need to clear that out a little bit. But if people are having issues with worms, there's one address, and that's info@marinespecies.org. Just let us know, because we're not always aware that there might be a technical difficulty or another thing that is not working. So please do inform us on that.
Can someone write that link into the chat? Or is the Menti, right?
This was the Menti,
but we can put it in the chat. Is that possible?
And the follow-up question, how should we enter some of the species not found in worms?
That's a good one. You just let us know that you have a species name or a taxon name that you cannot find in worms. Worms is good, worms is very good, but worms is not 100% complete, which means that there might indeed still be species or taxa that we haven't captured. We cannot capture them if you don't let us know. So anyone letting us know that they cannot find a taxon in worms gets a follow-up. Either we explain why it cannot be in worms, or it will not be in worms, or we just make sure that it gets added.
Exactly. Are you in the chat?
Yeah.
Can you write in the chat?
I can write.
Can you repeat, Leen, the address you mentioned?
info@marinespecies.org.
Okay. Thank you. Thank you. Any other, or even comments? Doesn't have to be questions all the time. No? Nothing on the Menti, nothing. So that's my last question. 1, 2, 3, I ping and I change session. Anything on the chat? Anything on the... Oh, yes. Dave.
I suppose more a comment than anything else. It's just occurring to me through this morning's conversations. When you guys come to doing this in CS Mach 1 is not to be too prescriptive in your standardization of terminology. Remember, you're dealing with a whole plethora of data sets. Some of them are ongoing for possibly 30 years or more. So if you're too prescriptive, you will find challenges in accommodating that wide suite of data. Of course, you have to have minimum data standards, but you also have to be as accommodating as possible for it to work well. If you're too prescriptive, and if you ask too much, especially for people who have 30 years of data, they'll quite naturally tell you to take a jump, because there's, we've done it before for other projects, and it's just too much time, too much effort to try and reformat very large data sets to new standards that don't accommodate a wide suite of existing data standards. So you can maintain your data quality, but you have to accommodate particularly in additional factors that have been recorded as wide a suite as possible, and we've kind of learned that ourselves in trying to combine a variety of data sets from different sources. And also beware of codes. because with using codes, you lose resolution. So I would always kind of try and accommodate the raw data where possible, rather than coding stuff and then losing data resolution and data understandability as well. If you code stuff into, you define categories, give them codes, people kind of struggle maybe to understand what they mean, but also you lose that data resolution.
Thanks, Dave. I think this is touching on the point that this is all what it is about. We need this info, and that's what we're trying to grab from the people here in the room, of course, this interaction and this return on feedback on what we can propose, what we know, what is out there. So it's very important. And also what we put this question on the Menti for people online to be able to tell us what they think. It's not just for questions, it's tell us this is good, this is rubbish. We can hear it. We can. Okay, but I guess we're gonna move on, right? So we have a bit of time, but thank you very much. So we jump into the next session. Peter, you want one of this one?
Okay. Yeah, as we saw yesterday in the poll online, and I don't know if the vision of the participants online is still the same. We saw that biodiversity was the largest discipline of interest, but not far after was the litter. And now today we look into the litter citizen science case. Yeah, similar to before, we do now a short pitch of Roman's Sail and Explore Association data flow and the data, how they handled. And then we go online to Eugenia Molina. And then she will show what is the target, the ultimate goal, at least for the data management side, and some discussion around that. So Roman, take it away.
Yeah, thank you. All right, so I would like to present in the upcoming minutes a case study that we have conducted together with citizen scientists on the island of Elba and also around the island of Elba on collecting microplastic data. But first, briefly, once more, who we are for those who haven't attended the event yesterday. So Sail and Explore, I'm representing Sail and Explore with Swiss Marine Science Organization, focusing on smaller sized microplastics, like literally the invisible plastics, and we are working mainly or conducting mainly scientific expeditions on a global scale together with citizen scientists. So if anyone is interested, please go on our website, sailandexplore.com. You can see our expeditions, you can participate. We often also do have other researchers who are joining us on our expeditions. We do long-term monitoring. You get educated, you get trained, not only on the science part, but also on the sailing part, and you have unique opportunities to connect with local researchers, for example, around the Azores or in Italy. On the other side, we also do nanoplastic research and human health, but that's not the topic yet here. If you're interested into that, please reach out to me. So what have we done on the island of Elba? So the aim of this case study, which might also act as a template for others here in the audience, etc., was that our aim was to go out and within only 1 week, together with citizen scientists, conduct research on microplastics and do a monitoring and figuring out how much microplastic can we find on the beaches of Elba Island and also in the surrounding waters. And the idea was really to do this in a very small time window, so 1 week, a lot of women power, but also push the educational and training aspect. So to give those people a unique opportunity to learn from the experts. We involve 6 experts from the plastic field who helped out with that. We have about 20 citizen scientists, and as I already mentioned, the whole thing took place during 1 week. We focused on 2 different setups, on beach sampling, but also surface water sampling. To do so, we organized a sailing boat. So one of the experts arrived with his own sailing boat, and
So this happened simultaneously. We had teams who collected at the beaches the litter or the plastics, while the other teams were hopping on the boat on a daily basis and collecting surface water samples. For the surface water samples, we used the classic Menta trawl. And for the beach sampling, we followed the marine strategy, or just in general, we followed this marine strategy framework directive. And it was very important for us that these citizen scientists really got an insight into how to follow up scientific protocols, really, because, I mean, that's what we are discussing here, right? Yeah, so the sampling sites included the north and the southern part of the island of Elba. Why north and south? Because on the west and on the east, the beaches are not sandy, it's rocks, so it's not possible to collect beach samples. That's one issue, or one thing. The other thing was also the weather dependency, specifically also of the boat, because having the boat in the port in the south of the island of Elba, then heading up north means you have to invest 3-4 hours to be up there, and you never know about the sea state, etc., etc. So there's all these things that you need to involve. You can see also on the top left here how we did the beach sampling. So again, this was accordingly to scientific protocol. So we defined clear transects of 100 meters. We had squares. We had the 1 square meter squares. Collected the sand, brought it back, and then did some further analysis. So the sample analysis included on one side so we did like the analysis included beach sampling analysis and surface water analysis, And obviously, it's not possible to include the citizen scientists in all these tasks due to mainly contamination issues. And that's also one big thing, specifically in the litter area. If you do citizen science studies, you always face these issues with contamination, right? So you really need to take care, okay, what are you monitoring? Can you monitor everything? Yes or no? One big issue, for example, are fibers. So fiber contamination deriving from our clothes, etc., is a huge issue, specifically then in surface or sea surface water samples, for example. So what we have done is we have on site on the island of Elba, we have set up a field lab, and we included the citizen scientists as much as possible into the analytical approach. So they were able in helping us with the beach sample analysis, which nicely worked out. If you're interested into that, please read our publication or reach out to us. We can definitely support you and guide you through how you can do that. So there is no real lab needed for that. But then on the other side, we also had to do obviously some real lab analysis, which took place then in Switzerland at the University of Bern, specifically for spectral analysis to figure out, are we really looking at plastics, yes and no? Yes. So what about the data outcome? I'm not going to numbers or whatever. Again, if you're interested into it, please read the publication. I think what is more important is to talk about, okay, what can we show, what can we present with this data, right? If we do this plastic litter data collection, and on one side, the outcome obviously is that we can count the particles. So on the top left, you see that. It's also about, okay, the colors that we, for example, see from the plastics, but also the shapes. So is it a film, is it a fiber, is it a fragment, is it a pellet, etc., etc. But what is of big importance is what you can see here, the table on the bottom right side. This is, again, the contamination. And we communicated this also clearly to all the participants that we will have a good number of contaminants, right, of these fibers. And you can see those numbers, for example, down there. It's just happening because we are many people, we cannot take care about that. So in the paper, we also discuss this, and we also make it very clear that fiber contamination, working together with citizen scientists, is a big problem, big issue, and needs to be clarified at the very end. On the other side, it's also the sample handling. A lot of research, specifically sailors who collect, for example, ocean samples, which is great, need to take care how they handle those samples, right? If you add them into a jar and you have certain very brittly plastics and you shake something, you don't handle it properly, these plastics fragment down into 20, 50 particles, and you don't really look anymore on the right numbers. So it's small things that need to be taken care about, but it's important that we do that. Otherwise, we have always certain biases, because we anyway have already a lot of biases in our data, because there is no perfect world out there. So if you look on our metadata, maybe quickly, I hope it's not too much of a mess here. And it's also not all the metadata that we collect, but maybe just to give an insight into people who haven't done this yet before, maybe. So this is the metadata, obviously, from the boat sampling. So what is really important is obviously that we write down, okay, the exact date, the time when exactly our mentatrol got deployed, when we took it out. And again, we are sticking here very close to scientific protocols, the GPS coordinates, when we deployed it and got it back in, so that we do know, okay, where exactly we collected the samples. And very important, obviously, to understand what was the water volume we were sampling through, right? Because we need to understand, okay, how many plastics can we find in 1 liter or 1 cubic meter volume of water, and not only saying, hey, there are 5 PET bottles floating around on the open ocean. And another thing that is also very important, obviously, is the area. So, for example, also includes the surface area of the mouth opening of the mentatrol. So it's all this small data that is important. Obviously, then the counts, etc. At the bottom, you can see how we just then present this data maybe in a different way. So particle counts per square kilometer or per cubic meter of volume of water, etc., etc. For the beach sampling, it looks almost the same. Obviously, there is a bit less, because we have here mainly GPS coordinates, counts, and time. Obviously, we don't have water volume, etc., etc. Again, you can see on the bottom right how we did the beach sampling with all these transects to have like replicates, triplicates, right, to really have strong data. That's also very important. Maybe I can highlight this quickly, that in this whole microplastic community collecting sea surface samples, what has been done, including also us back in the days, was mainly collecting data at one single point, right, at one specific time. But that's only a snapshot that you get, right? But we all know that the open ocean is moving. We have the wind, we have the currents, and if you go there 2 hours later, the situation will look different, right? So monitoring is really important, and citizen science definitely can have a strong impact into this monitoring. We just need to really understand and figure out the best cases, best practices of how to implement this with the citizen scientists, that they get educated, trained well, that they can really contribute to this. Yeah. So on the other side, maybe for those who don't know how that looks like, so when we collect all these samples, we process them, and we try to somehow get rid of the organic matter, and we end up with filters with all these plastics on it. So you can see we all number those guys, and then we just measure them. So we measure the different particles, length, width. We categorize them accordingly to the classic categorization, fragment, film, foam, you name it. Colors, and what we also do, as we are publishing always our outcome in scientific peer-reviewed journals, we also do spectral analysis to really assure that what we are looking at is really plastic, right? So here I don't show clear spectral data, but you can see one example down at the bottom left. But on the top right, you can see here then we define what kind of material it is. Is it a polypropylene, a polyethylene? And you also can see the quality of the spectra that you can get. Last but not least, up to now, we always handed over our data to NOAA, to this marine microplastic map that they introduced it into it, which is great. I think what is of importance to mention, just in general, I think those maps are all great in the plastic litter world. However, I think what is a bit of a problem is if you look on such a map and you see all green, orange, and red dots, for example, then you might get a wrong picture of it, because if you don't know at what time, year, for example, those samples have been collected, then you don't get the right picture, right? Because if you go on certain maps, you can see data that is 20 years old. and it's just next to data that is 1 year old, and it's all together, you know. And I think that should be considered in the future, maybe, or just in general, to really visualize this data in the best way for everyone, that people also understand it in the right way, or otherwise we always make different outcomes or whatever. Yeah, so sorry, there is something wrong with the layout. Anyway, last thing I would like to mention is just when you conduct this citizen microplastic litter citizen science projects, for example, I think it's very important what are you focusing at, and size does really matter, right? So if you look at macroplastic, it's much easier to do, it's more feasible because the contamination risk obviously is almost zero. The time duration is also easy to handle because you can bring people to a beach collecting samples over a longer time frame, etc., etc. But if you go into smaller size plastics, microplastics that are below maybe 1 millimeter, that's just not feasible anymore to work with citizen scientists. So yeah, size does really matter here. And then again, depending on what you want to do, I mean, there are certain things that have to be still taken over by academic research, specifically if it's about the analytics. But nonetheless, I think there is, and we all already know that, and we have proof for it, there is a fair chance to initiate good citizen science approaches within the litter field to get some really good and strong data.
Thank you. Yeah, have a seat here. Yeah, thank you, Roman. You already said in our pre-talk, we're not the average citizen science initiatives in the sense that you did a lot of studying already on the protocols, on how to do citizen science. So yeah, you've a lot to contribute, I think, to the community of litter citizen science. And yeah, we now make the step then to Eugenia, who looks from the EMODnet chemistry perspective. First of all, I think quite generic, and then also a little bit related, analysis related to Cyril and Explore, but that will be quite a challenge because it was already quite thoroughly done, I think. But I leave it to you, Eugenia.
Yes, thank you. Hello to all. Quite impressive, Roman. Looking forward to have the data from Cyril and Explore in EMODnet because the whole setup is impressive, and moreover, when you see this data with a lot of metadata and the scientific approach, as a data manager, you say, oh, wow, I want this to be in the infrastructure, to be reused many, many times, and to create knowledge. So looking forward, yeah. So, okay, yes, I have a couple of slides to describe the data in EMODnet, the data of pitch and microliter mainly, because that's what we have in relation to citizen science.
Eugenia, one minute, because I think your slides are not shown yet.
Yeah.
And so can we move forward? These are your slides.
Yes.
But not the right page.
No, back.
Okay.
Back. Okay, this one.
Yeah, you can just say next. Yep.
Yeah, okay, thank you. So in EMODnet chemistry, you have been hearing these days about EMODnet and about the different thematics. So in chemistry, we deal with the litter data. And at the moment, we are managing beach litter data, macro litter, seafloor litter data from trawlings. And talking about microliter, we deal with floating microliter and microliter in sediment. The first important thing is to have the metadata, as my colleagues mentioned before, the what, where, when, who, and how. And these metadata are codified by standard terms, standard ways to give the information. For example, when we talk about the WHO, we relate to the ETMO catalog. I didn't put the reference, but Peter can also talk about them more explicitly, as they in MARIS manage the catalog. And this is a standard catalog that contains the information related to the institutions that collect the data, and it's very extensive and covers the whole world. And in this sense, you can, if you include this information and in a standard way, you then can come back to know who has reported this data. And it's also, there's also another catalog, which is the EdMERP, which is related to the project that has been in which the data has been collected. And with these catalogs, you have this information in a standard way, and you can always relate if it's information from a citizen science organization. So this is the first important point. And then when we come to the data, for beach litter, we have some guidelines that describe how this data have to be reported, and with the links to all the catalogs or the standard vocabularies that are needed to describe this data. And in the guidelines, we have also the links to the tools that allow to validate and to format the data. I've put in the presentation, I don't know if you're going to deliver the presentation as well, but I've included all the links that are there to help for people to, if it's interesting for them. And in beach litter, we also have a catalog of the beaches, or a map, a service that includes the map, which is shown in the right side of the image, with all the beaches that have have data in EMODnet database. In this way, when someone wants to report data to EMODnet of beach litter, can go to the service and see which is the name and the code of the beach, which will be useful to report the data in the template. Finally, when all the information has been included in the format, in the template, then it can be validated. And if the data is valid, if the file is valid, because it contains all the information needed and in the way that it has to be reported, then data can be sent to EMODnet. I have included the link of the EMODnet ingestion service because as our colleagues of biology explained before, EMODnet is a partnership, so every cycle of the project has certain partners, and you can not become a partner in that phase. But EMODnet has a nice service, the ingestion service, which allows you to send data to EMODnet even if you are not a partner of it. And this is great, I think. So through the ingestion service, you can send the data formatted, or you can send the data as is, and it will be a part of EMODnet. When it comes to microliter, the information is a bit different. Roman has included a very good example, and even though our format is a bit different. More or less, the information that has been shown by him is the one that it's needed. In EMODnet chemistry, we have also guidelines and formats to send the microliter data, and the vocabularies that report the data in a standardized way. Next slide, please. So this is the beach litter format. It's based on an Excel file with 4 tabs to report the information regarding the beaches, regarding the survey, the animals that might be found during the survey of in the beach, and the litter categories and the quantities. This format is based on the OSPAR data format for beach litter monitoring that was developed in 2010 by OSPAR, and we've been using it for, well, since 2017. All the information is codified in standard terms that are from vocabularies that are hosted in the NERC vocabulary server of BODC, or some of them we have created and are made available via service at EMODnet. Next slide, please. When we talk about floating microliter, we have this TST format containing all the information and the header that makes the links to the metadata and to the standard vocabularies to describe the parameters. We have, this is we call it ODB format, but it's a TXT file, and it has some mandatory data, which is the cruise, the station, the date, the coordinates, the link to the metadata, and the ITMO code, which describes the institute that handles the data, and the bottom depth. Then there is some more information that it's also mandatory, but it's related to the microliter, and it's the sampling effort, the coordinates, the microliter morphology, the size, or the count. And finally, we have some other additional information that you might report it because it's also important for comparability, but if you don't have it, it's not a problem to include the data in EMODnet. And next slide, please. This is also the template for the microliter in sediment, which is very similar to the floating one, except that the information regarding the sampling effort, of course, is different, or you need to, or you might report as well some parameters regarding the composition of the sand sample, etc. And next slide, please. And finally, these are some of the vocabularies, the standard vocabularies hosted at the BODC regarding the microliter. We have some more than these ones, 2 or 3 more, but these are the main ones as they are related to the morphology of the particles, the size, the color the material that compone the microliter particles. We have another one for the transparency of the particles as well. And yes, I think that's it. And yes, as far as I've seen, what has been shown by Roman is their samples are more or less codified using the same terms as we already use, for example, for morphology and also the size. So, well, we can now discuss maybe a bit about it, but I think he has told a lot about the samples, and I don't have much more to add, Peter. Sorry.
You're doing too good. But that's also, I mean, it's a good sample case, example case also that we can hopefully show also on the CS Mark 1 website. So we not only show your contribution, Evgenia, with the guidance and the guidelines, but then we can show the data as is. And then you already indicated we would love to take up this data in EMODnet chemistry, the EMODnet litter collection. So, and hearing this, that should maybe only include a little bit of conversion here and there of values. Maybe they're just a little bit different categorization, but if it's already categorized, that shouldn't be not a big problem. So,
yeah, and for example, one very important point is the sampling effort, but they collect not more than one sampling efforts, like the volume, the area, the length. So yes, it's more than complete. Yep. It's good.
Okay. Yeah, and we have, well, at least yesterday, we had quite some people involved with litter, beach and micro, I guess, also online. So yeah, shall we check the questions in the room and online?
I have one.
Okay.
I have one. I have two. I have maybe three. I'm just very curious about. It seems to be a light job to come up here between to have the data from the Sail and Explore Association to the EMODnet marine litter. Did you know of each other before?
No.
No, honestly not, no.
This is the success of the network. It's the first success.
Yeah,
and I can assure that it's not always like this. It's usually very complicated.
I mean, I just wanted to say that I do hope that our data looks good, because we are the researchers, right, who work on it, and we are kind of like try to show how things need to be done and etc. So I think it would be a bummer if we make a lot of mistakes, to be honest, because we are also part of like shaping such networks. And on the other side, I mean, the data, the metadata that I showed, that's just like one way of how to visualize the metadata, right? So for us, I mean, if we need to feed your EMODnet pages, right, for example, that's a no-brainer for us, because in the background it's even more simplified, the metadata, so sizes and everything can easily be extracted and then just incorporated, implemented. Yeah.
Thanks. Another question I had, and I promise I'll let you talk afterwards. To Eugenia, is EMODnet Marine Litter working with NOAA on litter?
We are collaborating in the international initiatives, not directly with NOAA, but the Ministry of Environment of Japan has this mandate of the G20 to create this global monitoring initiative of microliter called EurOBIS, and we have been collaborating in this context in relation to microliter. And also the UN Plastics Hub, you might be aware of this initiative, has created this group of experts and is collecting also data from the whole world of beach litter and microlitter. And there have been discussions around the harmonization of this kind of litter data. So we are collaborating with NOAA in this in the context of these two initiatives. Yeah.
Okay, thank you. Now I stop with the question. I give the floor.
Okay, and yeah, as you indicated, there are already some citizen science data flows going in to the litter data collection. So you are used to handling this, and also possibly via data ingestion, EMODnet data ingestion. So yeah, the door is open for others.
Yes, the door is open, and especially when data is good, because it's worth to give users the possibility to reuse them, and the citizen science as well gets much more impact in their activities.
Yeah, perfect.
Yeah.
Checking in the room first in the back, and then we're going to check also questions online. Ziggy, do you have something online? Yeah, okay.
Hi everyone, nice to meet you all. I'm Charlotte. I'm also working for VLIZ for the data center. And I'm involved in several projects that have to do with plastic and litter. And I've also worked with citizen science data on that subject. And just to answer your question, Roman, about whether your data is of good quality to flow to EMODnet, from what I've seen in your presentation, it looks already quite good. Because I've seen other things, and I see that Maria is also nodding.
Yes.
Yes. In my experience, sending data to EMODnet is not always easy for citizen science projects. First of all, because for example, for beach litter, you need to collect quite a lot of extra data, metadata on the beaches, which is often sometimes forgotten. So if you don't collect it from the start and you need to collect it afterwards, it's a bit more difficult. So that's something to keep in mind before you start collecting data, that you also collect or check the guidelines of EMODnet first. Because it's a very good platform to send data to give visibility, for example, to your project, and to for policymakers to make use of your data. And a second thing is that EMODnet, I think, requires also to have, for example, your macroplastics categorized in, or macrolitter categorized in with a reference list, for example, the J list, the joint list. And I think for citizen science projects, it's not always easy. I'm working, for example, in the Plastic Pirates Europe project. Don't know if someone knows it, but they use other categories, more simple categories. And yeah, that's also something difficult, because you need to keep the protocols for citizens simple, but at the same time, yeah, you need to the data need to be useful for researchers, for example, and there's maybe a gap between aligning those simple categories with those reference lists, for example. So that's a difficulty we encounter sometimes. That's just a remark.
Yeah.
No, two very important remarks, I think. I mean, the first one is really about the protocol, and let's hope that the CS-BAC1 network will be that strong that people, before they start collecting, actually knock on the door or look to what is minimally expected, because it's a waste. Yeah, it's such a pity if a lot of effort have been made on collecting beach litter, counting, but then if you don't follow the right protocol, or you haven't, like you had a very structured approach with 100 meters, and if you don't follow that, or you don't you use categorization that cannot be converted because it's the wrong, it's too broad. You cannot chop it into smaller categories because you don't know how it relates. Yeah, that's so. I hope also in this perspective, so not only in the data handling but also on the protocols, we can spread the word in the network.
Yeah, I think we need to ensure that we record these kind of comments in our system. I don't know if you enter it in the Menti. I mean, now we have it in the video anyway, so that's okay. But this is all very welcome. Thank you.
Yes, and for example, one thing that could be done, because in EMODnet format, which seems very large for VLIZ, and it is probably, but not all the information is mandatory. So one thing that it could be done by the project is make just a small guideline, a small sheet to help regarding the mandatory information that has to be collected when you go into the beach to make survey, in order for the data to be included in EMODnet, of course. And regarding the use of the list, and I understand what you say because it's much more complex. But on the other hand, if then you include the data and you don't use the standard categories of the different protocols, maybe, of course, maybe the J list is quite complex. But there are other lists that might have less categories. If you don't use a standard list, then data might not be useful for almost anyone. So if you make a lot of effort doing the surveys, collecting the data, including the data in EMODnet, and then this data is not useful, is it worth doing it? Maybe it's better to put some effort in doing less. I don't know, it's a reflection. Maybe it's a kind of controversy, but I don't want to be picky, but I don't know, it's how I see it
Maybe one
as a scientist.
Maybe one thing that I would like to add here is there's a bit of a jungle out there with different platforms. And I work with a lot of different non-profit organizations together, and they all claim, or I don't know if they do it, but they upload somewhere something, right? And I just saw it also with the beach litter, for example. There are a lot of different types of protocols, and I think it's very important that we somehow figure out how can we communicate to all these citizen scientists or initiatives that want to use citizen science, right, to gather this data. What are the best practices, etc., etc. I mean, from our side, obviously, that's what we do, right? From a research perspective, with Sail and Explore, it's one of our main tasks to do this education, proper, have a very clear communication, showing state-of-the-art research, explaining why things are done as they're done. It's most often very simple, but people still don't understand it, because otherwise we always have this huge swamp out there of semi-good quality data, etc., etc. So I think it's of big importance that this EMODnet, for example, also gets very good visibility to non-academics and other organizations.
Thanks. Then do we have time?
Yes.
Yeah. Then we go to a couple of questions from online. Ziggy?
Yes. I have a comment here. Proud to announce that the Sea-Watch B beach litter data for 23-24 are accepted this month in EMODnet chemistry. That's from Nancy. So congratulations to the team from the VLIZ Data Center. And there's a question for Roman here that I want to pick up. Maybe I just missed it, but this is what it says here. How do you perform the contamination control when looking at nano and microplastic samples?
Yeah, we don't collect nanoplastics in the environment. That's only stuff that you do in the lab. So just one sentence to the nanoplastic. We have established an approach, a synthesis approach to make nanoplastic particles out of bulk plastics, so ocean-derived plastics or environmentally found plastics, or just packaging plastics, for example, food contact material. But we don't do any nanoplastic research with environment, right? That's this. And if it's about microplastic and contamination, then one needs to take care, for example, to have airborne contamination, to look for airborne contamination. So you have like filters, for example, on the boat, and whenever you expose the sample, like the net, to the air, you need to take care that you also look for this airborne contamination. And literally every single step, whenever we do any processing of the samples or analysis, there is always a control next to us, which is most of the time just a simple naked filter next to whoever is doing some research to see if there is some airborne contamination. However, if you go then into sample processing with chemical digestions, etc., you also need to consider different controls.
All right, and I have another very interesting one. This is a quote, "I wonder how much non-beach litter data you have. We in Coastwatch see an underrepresentation of, for example, aquaculture litter." I mean, it goes to both of you or anybody else in the room as well.
I mean, at the end of the day, for us, again, this was just a case study, right? Our focus is on sea surface water sampling. And this case study, I mean, if you collect beach samples, you need to understand that from where can this plastic come from, right? So it's either deriving from the ocean because it's just washed ashore and it stays there, or whether it's just tourism, and obviously it's both, right? So, and then at the end of the day, you need to understand how you interpret this data. What I can, for example, mention, we did a study at the Great Barrier Reef, sampling at a specific location in the open ocean, and we couldn't find almost any plastics in our manta trawl nets. And I'm kind of like, wow, this is super pristine here, how comes? But then we had a deeper look into the smaller size fractions, so we sampled down to 50 microns, and we saw that we have more than 100 times more of the smaller sized plastics in the nets. So, but we ask, okay, but why can we not see bigger sized plastics? And then we figured out that there is a non-profit organization close by who on a semi-weekly base goes out with citizen scientists, and they collect everything they see on the beaches. I don't know if this has an impact. I guess yes, which is great to see, right? Because whatever is gone and cannot go back. So yeah.
Was this ever published?
Yeah, we published the data. If you go on our website, you can see the publication. If you don't have access to the paper, reach out to me or us, and we can forward it to you. So everything from our side is going to be published. We're a bit behind with the publications, but this year we hope we end up with 5-6 publications.
Yes.
In the back, do we have the microphone for Charlotte?
Just a comment regarding the litter from aquaculture. Both in beach litter categories and in the litter categories for seafloor from trawlings, there are fishing and aquaculture related items. So yes, it's quantified and classified as well. And the European policies make a lot of effort in getting to know how much litter data from aquaculture or fisheries is out there. Yeah.
Thanks. Charlotte?
Yes, just a small question for Roman. If you talk about data publication, from what I hear, you published the papers, but are the data also published separately? Because for us, data publication is really publishing the data set on its own. with a DOI, with an identifier, etc.?
Yeah, sure. I mean, we just do classic academic publication, right? So at the end of the day, we have some supplementary information, or we try to, if possible, publish open source or free, and that's it. But I mean, again, so therefore, we're more than happy to provide all the data that we have for like EMODnet, right? To give this metadata real visibility, because obviously, in a scientific publication, you most of the time don't see the metadata. You only see the treated data. Yeah.
Okay, thank you. I want to make a small remark, or maybe first a question to Maria from EMODnet. Are there plans for EMODnet to provide a DOI, for example, in the future to data sets that are submitted? Because now we first publish the data with a DOI so that we can transfer it like this to EMODnet for proper reference, etc. But are there plans with EMODnet to apply this in the future within the EMODnet system?
Yes, of course. We will try to incorporate it, because now more and more it is really fundamental to couple the DOIs with the data sets. Yep.
There is another question for Roman. Did you reuse existing categories and vocabularies, for example, from NOAA or another organization, for your classification of microplastics, or did you come up with your own?
No, we didn't come up with our own. We are following, as already mentioned, scientific protocols. So, and I don't know even if NOAA has their own terminologies, to be honest. So at the end of the day, just for those who don't know, if you go on this microplastic map of NOAA, they literally only incorporate published data. Okay, so it's not really citizen science data that you can see. It might be that citizen scientists have been involved, like with what we do, right, with our expeditions. But at the end of the day, so they only publish or show or visualize data that has been published in a peer-reviewed scientific journal. That's it. So therefore, sorry, it's also a bit limited, right, with what you can see, big time. And again, so I just mention it again. When you go on this map from NOAA, then you have data that is 20 years old next to data that is 1 year young, right? And you need to click on the goddamn button to see it, right? If you just look at it, you might just think, oh, wow, right? It's almost nothing there or so. But you don't really understand the situation. I think this is really an important aspect, that we present and visualize this data as good as it gets, that people can work with it. Right?
A time slider underneath the map would help.
Yeah.
Yep.
Yes.
Okay.
I think we're getting close to a conclusion.
So I'll hand over to you again.
Yeah, thank you. Thank you. We're arriving to the end of the workshop, and I'd like to have Viviana, Antonio, Patrick, and Peter here on the stage, please, for some concluding remarks. I have a couple, of course.
And Emily, you get going. Start it.
So we probably need the microphone, all of them. Thank you. So here you have some microphone to play.
We have a bunch of them.
Yeah, I'm here. I need to
go do it, because you have to. So say it.
Well, we'll say what. Yeah, I think I want to say a big thank you for the people who make that workshop possible. So, which is on site, and Nancy, hi, thank you, thanks for everything, because she's online. We also have other people online from the consortium, Camila, Laura, there's other people also. So thank you very much. Of course, the people in the room, there's no doubt about that. But this is also very important to say a big thank you to you who took the time, took the effort, the energy, the funding to come and join you in the room. So this is also a massive thank you from all of us, because we don't do a workshop on our own. And the people online also, which I hope you've been numerous also today. We saw that there were a lot of people yesterday, but I followed a bit less for today. But one of the remarks that I have is that we saw that yesterday was quite different from today in the way we organized and scheduled the workshop. But today, to me, it became very clear that when we saw these different case topics, domain, disciplines, there's a lot of commonalities, but there's a lot of differences. And I think we have tons of materials here to extract and transform this information to make it easy, because I'm a citizen scientist leader and I come here and I listen to that and I'm completely lost. I would not know where to start to put the data. I would have no idea. So I think we have here, that would be my main conclusion, is that I think we have a lot of material. We gathered a lot of material over these 2.5 days. And I think that we have a good work of digesting it. It's going to take a bit of time. And I hope we're going to make it to a nice report. But yes.
Can I start? Because I had you couldn't have said it better with thanks to all, but just to follow up, for me, the main outcome, we were already thinking of how to start presenting this information in a digestible way to the citizen science initiatives, to the experts that want to contribute. And we had a vague idea before this workshop to do this the clear idea was we have to do this thematically or discipline specific, and as you recognized, there is a big difference between them, so we have to. You come in, okay, you go left, middle, right, far right, you take the path that fits you. But then I think we got a very good overview of what is already out there to say, okay, standards, go here. Drop your data, go here. Training material here, training material on X, Y, Z. So, and there is already out there, but I also see some gaps, also from ourselves, for the perspective of physics. We have it everywhere spread around, but we need to formulate it. So that's the take-home message that I bring home, at least. And it has to be put online quick, because we have to use the momentum that we have now with a large audience online. And ready to go.
I'll just echo you, Peter, because that's what I got in here too. It's exactly the same thing. But also I've seen examples of activities going on that I wasn't aware of earlier, and I want to see this in as soon as possible. But it's also a little bit frustrating because we're not there yet to have all the tools to enable this in an easy way, and this is the key challenge for us now, is to pull that together. And do it in a way so it's avoiding too much complication, and to just make it happen. But it's amazing, everything going on around. And we just keep adding stuff to the list on a daily basis of people who want to be part of it. It feels like it's a full community has been waiting for something like this just to happen and start pulling everything together. And this is where we are. It's early days, and we're constantly learning things on how to address it. But now we gotta get to action now.
Yeah. This is something that we need to add on the website as well, because we had a lot of people. We thank again. I'm seconding the thanks to the people that are online, because it's important to keep collecting, information about the project they are doing, but also we recorded that there is a very good willing of sharing, of enabling technology, knowledge transfer to one initiative to the other. So again, we can be, let's say, like a sort of mediator of this. So it's important to keep collecting and also showing how we can progress with all these initiatives in an easy way.
Yeah, exactly, and also allow feedback, because I liked it very much that people were contributing in the Menti and in the questions, because we can propose anything, but if it's unworkable or if there's gaps or if things are missing, this button respond to us on any topic is really important for us.
And that's creating the network and doing exactly that. And that we're building this network where everyone needs to feel part of it, and everyone has to feel they're contributing to it. So this is a key. So we build it together. We're building trust in the system, and let's go for it.
Yes, what I saw in these days is the fragmentation. So I think that CSMAC1 must be really the network and the point where people can ask and have a feedback. This is the thing. So it was important to meet all of us, all the components, the different point of view of the citizen science, because we see the data manager, but we see also the uncertainties from who collect the data, and they or maybe don't know that they can also provide data to EMODnet. They don't know. So CSMAC1 must represent this union, no? Because the information is fragmented. So we have, through the website, through the sharing of knowledge, through this kind of networking meetings and other kind of events, try to share the information and try also to make simple things, because this is the key point, because you see the metadata, data manager that are more related to the research. We are speaking about citizen scientists. Maybe the initiative and who manage the initiative is more comfortable with this information, but we have to think to people. And so try to make simple all the procedure and try to share through CSMAC1 the guidelines and the best practices to do this possible.
And taking on that, also some material that we need to provide is also how you can find your data into this integrating platform, because now we mainly touched the flow from the projects or the citizen to these integrators. But we need also to help people to find themselves in these platforms.
And sometimes you are related to the initiative and a topic. CSMAC1 put together different challenges and together different kind of initiative related to different kind of topics, so they can also try to share the information and have also a vision of all the environments, all the aspects of the environments, and maybe a citizen science could also participate in other initiative, because it's interesting to do not only, I don't know, marine litter, but also biodiversity, and they can share all these initiatives in their regions, in their places, or an initiative can have also an idea to integrate other thematics in their initiative. So I think CSMAC1 really represents a key point to put together all this network, and also something more, because through the technology providers, we can also share other things, other aspects, and integrate the initiatives that now collect few data with other kind of data that can be integrated in their initiative, I think.
I just want to stress this simplicity. Things that we presented with the metadata today can be overwhelming sometimes. Now, we learned how to present these pretty complicated things in an easy way. And this is because we don't want to scare people away. We have to make it easy for people to contribute and join. And that's often how we work now. We reach out to initiatives. We always ask for a data sample. And we start as easy as possible. Just point us to something and we start working with it together with the initiatives to try to fit them in. So we have to keep it as so it feels like it's something that is manageable to join it.
But it is discipline dependent, because physical data in that sense is a little bit easier from a cost efficient sensor than we saw from the litter and the biodiversity. Yeah, but even there, let's aim for the simplest way. But yeah.
But we also show some successful examples. So it is possible. We don't want to scare people. We want to tell them that it's possible to create all the data for EMODnet or other portals. So it's possible because we showed how to do that. So the Roman example for litter or the VLIZ for biodiversity, we can do that. So it's, but our examples, all the other could take something from these examples, and we have to do this networking to try to share all this information and try to make simple for other people, no, that can collect other data and make them available to the science.
Yeah, the more showcases we get, the easier it's going to be. That's and the more, you know, the more initiatives we get, the more it's important that we get the showcases now, so people see that there's a change going on, because that also will create a better momentum in the whole sharing of the data and the information around. People want to get on board. If you see things, if it's starting to happen in CSMAC1 and in EMODnet with this data, others want to join. It's just how it works. We know that from past experience. So we really need these exemplars to go out and show wherever we go.
We wanted people to come in our club. We want them to join our club.
Yeah, and it's a nice club. We're having fun, so come on.
Join the club.
I think that having the data on EMODnet is important also for people that collect the data, because they can see the data somewhere and they can see they are useful. We see in our case with the water level and sea level sensor, the students download the data from EMODnet and analyze the data. It's quite different because they have the capacity, but it's important that they see that the data are somewhere and are useful for someone, for the science, for to study the processes and the system. So it's important.
And that could be the last word, important.
Join the club.
Yeah, we'll be in touch. I'll be in touch, and we'll try to activate even more that network we've been launching these past 2 days. We'll take your friends on board. We have some mailing lists. There are news that are distributed. So please now go in your life and spread the world. Spread the word. If you ever want to know anything, you know where to find us. And I thank you very much.
Thank you.